I didn't copy-paste those 3 times in a row. So I just highlighted a couple of points which I find particularly interesting in the concept of science. Stuff like the fact that if you're using any of the scientific packages, you can immediately see your data or your notebooks right inside the IDE. You have a plotting view which allows you to see the plots of your data directly. But yeah, mostly that's just more of the same goodness. If we haven't convinced you with this kind of yet, again, stop by, talk to us. We would be more than excited to. Now, one thing that I think we've also kind of all learned is that collaboration can be a challenge, but is also something that's really important. And one of the new products that we've recently introduced is Jabra in Space. So Jabra in Space is our collaborative platform that encompasses pretty much everything you need for professional software development. I've written up a couple of use cases here, so whether it's you as a software developer just wanting to have all kinds of things integrated into one, if you're working in a team, if you are managing a classroom and you want to make sure that different teams can work on their own submissions individually, or you want to be self-organized, that's something you can easily do with Space. Now, obviously when someone says an all-in-one solution, that can mean many things. For Space, we have a pretty clear roadmap of what we already have and what we want to have in the future. I've put up a couple of things here. These are things like Git hosting, code review, CI/CD, package management. Of course, we are vendors of IDEs, tight integration with our IDEs as well, which makes all of this quite convenient. We're more than happy to demonstrate that as well. I don't want to dive too deeply into that for time perspectives. Now, of course, collaboration, as we've probably noticed over the last year or so, is something that doesn't just happen on a macro scale. You also want this to happen on a micro scale, right? The experience of pair programming and being multiple people sitting in front of the same monitor and working on the same problems probably sounds a little bit familiar. And we recently launched a tool after a long time in development called Code With Me, which enables exactly this. Just as one of the technologies where, once again, I would personally say seeing is believing, but the idea is essentially this. Imagine just having one IDE, your IntelliJ, your PyCharm, your CLion, connect from multiple machines to the same instance. You can all work together, and you can all use the features that you know and love. That's everything from the debugger to running your tests to just doing a bunch of pair programming with the same kind of inspections that you usually see. And really, we try to make this experience as seamless as possible for people, meaning that you literally just send someone a link, they'll paste that link into their terminal, and they can just get started working with you immediately. The kind of key phrase here, I would say, is it's the same experience that you would have if you work in IntelliJ or CLion, but you get to share it with someone else, and they don't have to be in the same room. They can be on the other side of the globe. It'll still work just fine. Now, obviously, there's a bunch of different features here, and with static slides, the logic of having multiple people work on the same thing, it just doesn't come across. So, once again, my call to action. Stop by, we'll send you an invite link, and you'll be able to work on our projects live with us, because why not? But one thing that I kind of want to highlight especially is the combination between the fact that we have collaborative editing, but also pretty fine-grained permission management, which means you can also do things like read-only. So if you're teaching, give them full access to your computer, but you still want them to navigate the code on their own, or you want to kind of do like a code walk and show someone around inside your code base, or you're just kind of introducing somebody, that's something that you can easily do with Code With Me. But just giving them read access, automatically telling their cursor to follow, and they'll see everything that you do, or they can freely move around in your code base without any kind of issues. Again, one of the big endeavors that I think ICPC is pretty closely connected to is the whole idea of lifelong learning. And we, of course, also want to support both educators and students in their journey. So I want to briefly talk also about what we do. And this is one of my favorite slides because I don't have to sell you anything, because you'll get all this stuff for free anyway. So if you're a student or you're an educator, you get access to our JetBrains IDEs completely for free. That's our all products pack. So if you could name those technologies back on from a couple of slides back, those are the technologies that you can use for free. That's as simple as usually putting your email address into a form and then getting a registration code a couple of moments later. You can just install those locally on your machine and really start coding away, both at home purposes. Now, for universities, we actually offer a pretty similar deal. We also want to make sure that universities have access to our IDEs directly, for example, to staff computer labs. So we have a bunch of different setups that usually work with whatever configuration universities have. Again, for details, just kind of talk to us. That's mainly for programming classes, but for example, if you're teaching software engineering classes in particular, and you're interested in something like JetBrains Space, we also offer free plans as well as discounted classroom plans that include even more features. You can see that on jetbrains.com/education, or you can talk to us for more of this stuff. In case it wasn't really clear yet in this context, the collaborative things that we have in Code With Me, for example, so just being able to invite a couple of other students, your colleagues, or people that you're currently teaching into the same session, that's all included. You can do all of that. There's no extra cost or nothing hidden like that. But we also go beyond this because, well, so far we've really just talked about the things that we have, that we build for professional developers. And the needs of professional developers might be different of the needs for someone who's just starting out or who's really just digging into programming for the first time. That's why we also have a couple of educational editions of some of our integrated development environments. Specifically, we have IntelliJ IDEA as an educational version, and we also have PyCharm as an educational version. And we'll see a little bit more about what that kind of contains, but what it boils down to is it's a slightly simplified interface for people that really focuses on the features that people use the most. But it also includes things that are meaning things like you can solve coding challenges directly inside the IDE, and we integrate with learning platforms. Now, those two IDEs are actually for free for everyone, even if they're not signed up at a university. If they're just studying on their own, they can always download these and just get started. And for all of our other IDEs, we also have an educational tools plugin, which enables the same kind of learning features even for the IDEs where you do need a license. So the key thing that we wanted to design with the PyCharm and IntelliJ educational editions is an experience where you can have all of your parts that you need to learn something new inside the IDE without having to tab out, tab back in, all these kind of things. So the way that it works, as you can see right here, is you can have the complete problem description for a coding challenge right inside the IDE. We have a new mechanism that uses placeholders so that you can fill in the blank kind of problems. And you can also submit your challenges immediately from the IDE with a single button and get immediate feedback, which kind of tightens that cycle a little bit of getting feedback and kind of iterating on your solutions as well. But of course, courseware does not fall from the heavens. We understand that if you are an educator, you probably have a pretty clear idea of how you want to teach people. You don't want to take some random course someone created and just say, all right, you just do this. You want to customize things. And this is why we actually included all the tools that are required to build full courses inside the IDEs as well. You can build those, so you can build those for free completely as well. And that includes things like rich problem statements, where you can also embed images and videos, all these kind of things. You can define your sample solutions and then mark placeholders for people to fill in, have automated tests so that students get immediate feedback or learners get immediate feedback. And the most important thing is that we're not trying to lock you into any kind of ecosystem or sneak in some kind of subscription somewhere. At the end of the day, you can export your courses as a zip file and just send those over to your students on whatever platform you have, Moodle, or you just want to send them a really big email. All of that's perfectly possible. Of course, we also offer integrations with learning platforms, for example, JetBrains Marketplace. We have a couple of these integrations. Probably for the main part of this crowd, the most interesting one will be the last one on the list, which is Codeforces, because you can actually write from your IDE, open up any kind of previous Codeforces contests, and start the practice with a single click, which means, again, the whole thing just pops up a window. You'll see the whole description of your problems. You can write up your solution and submit it directly from the IDE without ever having to leave it, which might just be like a convenient little experience. Now, we also have some endeavors at JetBrains where we are rolling out our own learning platform, and that would start with, well, JetBrains Academy. So let's talk about that a little bit, because we found that teaching people programming is a really interesting task, but it's also a really challenging task. And we found that for a lot of people, it works very well when they have something that they anchor their knowledge to. So with JetBrains Academy, we essentially built a project-based learning platform. You pick out some kind of problem, or you pick out essentially some kind of project, which is like the guiding thing for what you want to do. You say, okay, I want to build some kind of calculator app, a bill splitter, or whatever. And then you just kind of complete stage after stage, task after task, and at the end of the day, you'll actually end up with a full project. And of course, this is always hard to pace for people, because different people have different kinds of like previous knowledge. People sometimes already know things, sometimes they're missing like just that one little thing. And this is kind of where our knowledge graph comes into play, where essentially we have a dependency graph of all the things you need to know to solve your problems or to solve these kind of projects. And depending on your previous knowledge, we just kind of like different types of tasks that you like, different types of topics that you can usually complete within 15 minutes as a single unit, closer to what you need to submit to solve your problems. These also include things like code challenges, which once again, with a tight integration with our IDEs, single press of a button, you can solve them inside IntelliJ IDEA, C-Line, or whatever. But it's also things like quizzes. Now, we actually have a bunch of different tracks, some of which might also be interesting for you, because I'm sure that, well, maybe if you're learning a new programming language, it might be interesting to, you know, just do it with a little project. I personally know from experience that it can be kind of hard to find that initial motivation or that initial like little problem that you want to solve with a new language, so that might be a little bit inspiring. But also just if you want to learn a new industry-proven framework, if you say you want to know more about how you're becoming a back-end developer, Android developer, all of these things, or you want to just see some implementations for certain algorithms in a different programming language, JetBrains Academy might be an interesting place for you to stop by. Something that we're of course also very excited about, because we are Kotlin people at heart, at least I am, is the fact that we offer two new Kotlin tracks, and that's the Kotlin Basics track and the Kotlin Dev track. Now the Kotlin Basics track is available for everyone for free, and kind of gives you a first taste of the language and takes you all the way to the point where you can already be productive. And then with the Kotlin Developer track, where if you have a subscription for that one, you can also learn some advanced topics of the language and become a real professional Kotlin developer in probably no time. So if you are interested, especially in that second track, we have a QR code here. I was told to make a gesture so that people can know what to scan. That will give you access for a little bit longer. If you keep self-learning, we actually kind of continuously extend your free trials for a while, so you might not have to end up paying at all if you just keep at. We're just trying to motivate you there in that regard a little bit. If you currently don't want to scan code because it's just kind of awkward sitting like somewhere back there and the phone camera doesn't work and it's all smudgy, just stop by our booth again and we're more than happy to share that with you as well. Now, super briefly before we move on, because I don't want to take much more of this time, we're going to talk a little bit about Kotlin, a topic that is very dear to my heart, as I've said beforehand. To just kind of, get everyone on the same page, Kotlin is a programming language that we at JetBrains kind of conceived for the first time out of our own need to be more productive on the JVM. It's something that we started back in 2011. It's a language that's completely interoperable with Java, And when I say that, I mean that. It's to the point where you can literally instantiate a Kotlin object in Java the same way you would instantiate a Java object, and the other way around. It's also, of course, an open source project for us, but the big goal that we have with this is to make programmers a little bit happier. What we're really glad about is that the educational space has also kind of picked up on this language as well, with over 190 different universities all over the globe already teaching Kotlin. We're also very excited that during this symposium, we're also going to be talking a little bit more about Kotlin in education and for universities, because we think that it can bring a lot of good to people, and it might make people enjoy programming just a little bit more. Some of these universities, if we want to be braggy about it, 26 of the top 100 universities in the Times Higher Education rankings already include Kotlin in their course. And of course, if you are in a position to move a course to Kotlin once again, or that's something that's interesting to you, you know where to find us. We're right up there. I think we're the only booth that has a really nice glowing logo, which I think very much sets us apart. If you actually are more of a hands-on type learner and you want to compete with a couple of other people who also write Kotlin code, then we of course invite you to our Codeforces contest called Kotlin Heroes. It has already started, and we're actually going to see a bunch of the practice round content in just a little bit. But on October 7th, we're going to have the real challenge, and there's going to be a couple of prizes for you to win as well. So just as a small little incentive. Well, that's all I have for you today. I know this talk was kind of all over the place. That's kind of in the nature of an overview talk. If any of those things were of particular interest to you, once again, come talk to us. We're here all week. Let me tell you, I can guarantee you, we're more than happy to spend even extended periods of times telling you what's going on. So yeah, stop by. Make sure that you have your free licenses, whether that's for yourself, for your classroom, or for your university. If you want to learn new technologies, make sure that you pick up your access codes for JetBrains Academy. And if you're looking for a job, or if you're looking to join a company where people are really passionate about making other people more productive, stop by, take a look at our internships, take a look at our open positions. We would be more than excited to have you. All right, with that, we're going to be moving on to Gennadi's part of the talk. So I'm going to be stepping off, and yeah, I hope you still have a wonderful event. Take care.
One, two, three. Hello, everyone. And thanks to JetBrains for inviting me. I must say that I did not mean to steal the show, and I was not in charge of the font sizes. Anyway, we have this Kotlin Heroes contest, which you have heard of, as of now at least. And it's held on Codeforces. That's the announcement, and the practice round that is running right now. So it's the 8th edition, and I took part in most of the previous ones. And I'd say it's a pretty fun and cool way to learn language and get out of your comfort zone, so to say. So let's try to solve the practice round. And just let's go. OK. All right, so this is the IntelliJ IDEA IDE, and I'm using the EDU Tools plugin to have the problem statements right here. So the first problem is just A plus B. How do we start? So we need a main, and then we need to read input from standard input. So the default function is readLine, but to read integer we need, like we can define another function which reads an integer, which is just convenient to have. It will be just readLine to int, and then we can have a function to read multiple integers on one line. And we need to map all of them to int as well. So that's how you can do that, and it's just convenient to have these functions in your template in general. And you can have functions for different types, for example, doubles, but we will probably not need them. And now we don't have to just answer one test case, we have multiple test cases. So to solve multiple test cases, we can just do something as simple as repeat read int times. Now we need to read two integers. We just read a list of integers and destructure it into two values, because we know we'll have two values. And we just print the sum. All right. In this plugin, we have the Run Local Tests button, which will just test the examples for us. Yeah, we can see the local test passed, so we can just copy our code and submit it. So we just paste it here. We submit. And in some time, it will be tested. Maybe we should not wait. I mean, in queue, it's OK. Queues happen. We can just go to the second problem in the meantime. So in the second problem, yeah, this one is a bit longish, but yeah, let's resize and take a look. So we have some kind of football match. We have n yellow cards shown to the participants in total. We have A1 players on one team and A2 players on the second team. And the rules of sending players off are a bit different. The players of the first team have to receive A1 yellow cards to be sent off, and the second team has to get K2 yellow cards to get sent off, like one player. And we want to know the minimum and the maximum number of players could have been sent off. Maybe it has tested? Running on test 5. We are going good. Yeah. OK, so this is kind of your math, like maybe arithmetic textbook problem, but also requires some case analysis. So first we can just read all the variables. We have the sizes of the teams. We have the numbers of cards. And we have the number of cards in total. OK, accepted. We have solved the first problem. Yeah, so what is the minimum number of players that? So each player on the first team can get K1 minus 1 yellow cards without getting sent off, right? So that number is number of yellow cards we can show to all the players on the first team without getting anyone sent off. And that's what we want to do, because we want the minimum number of players. And the same goes for the second team. Yep, so that's the number of cards we can show without getting anyone sent off, and every subsequent yellow card will send someone off. So the answer, let's say min, will be n minus this value. All right, almost there. Oops. Oh, sorry about that. That will be the minimum number. However, we don't want to get negative number of players sent off, so we should get the maximum of 0 and this number. And that will be the minimum number. What about the maximum number? We basically want the players to be sent off as soon as possible. So first, we can make the first team the team which needs less yellow cards. So if that's not the case, we can just swap. And we can swap this way. There is no swap functions because we cannot pass variables as references, but this is pretty short anyway. And then, if n is not greater than a1 times k1, the answer will be just n divided by k1, rounded down. And otherwise, we will have a1 players, and then we divide that by k2, and that will be the maximum number. OK, I should not do that. I should just have a variable max, define it as int. We will assign that to max. We'll assign that to max, and we'll print both values. We can do it like this. OK, let's see if we can pass the local tests. OK, we can. So let's submit. OK, that's kind of the process. This problem was just math. Let's go on. Hopefully, it will pass soon. Yeah, the third problem, we have n cans in a row, and the I scan has durability AI. And it means that if we have already knocked x cans down, we will need AI times x plus 1 shots to knock this one down. All right. So basically, it just means that we get tired. So for the first can, we need 1 shot, and then for each subsequent can, the later the in time shots we will need. All right. Maybe I should not switch too often. Yeah, that we just have to shoot the cans in decreasing order of AI. And we have to print the number of shots we need and also the sequence in which we should knock down the cans. All right, so we have n, we have a, which will be a list of integers. How do we find the order of cans? We can do it like this. So first we take a. Since we need indices of the elements, we can call the function with index, which transforms all elements into indexed values, pairs of index and value. Now we can sort them by descending, at least, indeed, by values. Yeah, and now we have the order. OK. Keep going. Yeah, and also let's find the answer. This will be easier to do just with a for loop. Yeah, so for can number I, we will need bi value times I plus 1 shots. Right? Should be right. OK, and now we print result, and we print indices. So we can use join to string of space. And then we also need to only take the indices. And also, we need to add 1, because we have 0-based indexing here, and we need 1-based indexing in the output. So we just it index plus 1 is how join actually. So let's test the solution. All right, so we have incorrect test 2 failed. And that happens because the order of indices can be arbitrary if there are multiple orders. So for example, in the second test case, we have 4 equal numbers, and we can just output any sequence, any permutation here. Since the plugin doesn't know, like it cannot check the answer, there is no checker provided by Codeforces, we can either like run all the test cases manually and take a look ourselves, or we can just submit, right? Because we just trust our instincts. In the meantime, we have second problem solved. Yeah, I suppose we will not wait for the third one. Thank you. Yeah, let's proceed to the first problem in the meantime. OK. We denote the function f of x, which is, OK, I suppose x is a positive integer. We add 1 to x, and then we remove trailing zeros in the number. Yeah, so for example, f of 599 is 6, and so on. And we say that some number y is reachable from x if we can apply function f to x multiple times so that we get y. OK, and then we are given a number, and we need to count how many different numbers are reachable from that number. OK. Yeah, I guess the main idea of this problem is that the number of reachable numbers is actually not that high, just because we will do in a trailing 0 is divide the number by 10, and then after at most 10 steps, we will divide the number by 10, so we will quickly get to a 1-digit number or so. So let's just simulate the process. So we have n. Yeah, it should be a variable here. Let's also have some set of added numbers. It will be hash set of integers. And now, while our set doesn't contain n, because if we make a loop, if we run into this number we have already seen, we don't need to continue, because we will obviously just see all the numbers that we have already seen. So we just add n. And now we have to apply f of n. We can just do it in place. So we just add 1, and now we need to remove trailing zeros. So while n is divisible by 10, let's just divide it by 10. And that's it. Yeah, then we try to add this number to the set again. OK, and in the end, we just print the size of the set. Right? Yeah, looks good to me. OK, third problem accepted, even though we did not test it on the samples, right? Don't try to repeat that at home. OK, we have tests passed for the first problem. Let's submit it. Yeah, actually, we can also, instead of checking contains and adding, we can just add it here. And the method add will just return a Boolean value whether the insertion was successful to work, actually. Let's just try it on the local tests. OK, we don't need to submit again. Yep, let's go to the next problem. We are given a string of characters 0s and 1s. And we want all 1s in the string to form a contiguous subsegment. So, for example, yeah, this is the example of good strings, and these are the examples of bad strings. All right, and we may erase some zeros from the string, and we want to erase the smallest number of zeros possible. All right. So we are not allowed to erase any 1s. We can only erase zeros, so all the 1s are kept in the string. And we want all the 1s to be to form a subsegment. So basically, we can find the first one in the string. We can find the last one in the string. And you have to remove all the zeros in between, right, between them. Yeah, let's just do that. So in this problem, we have multiple test cases again. So we just repeat readint again. Let's say we read the string. It will be read line double band because the value can be null. but we know it will not be now. OK, let's find the index of the first 0. We can use index of a char of 1, for example, right? Yep. There is a special case if there are no ones in the string at all. Yeah, for example, in this example, we have a string of just 1, 0. Then we don't remove anything. And in this case, index of will return -1. So if that happens, we just print 0. And otherwise, now we need to find the position of the last one. We can just use last index of 1 again. So we now have 2 positions. And we need to count zeros between positions I and j. Basically, we can just take a substring. Yeah, we can call substring with in different ways. We can call it from I to j, for example. I guess we can also make it I until j, or we can do it I double dot j, which is a bit different, but in this case, position j has 1 anyway, so it doesn't matter. You can keep it like this, and we count zeros. So that's how we can do that. And we need just to print that number, whatever. Answer. This will be some variable, and we just print it. OK, let's try. So yeah, obviously, like you can also just use some for loops. You can use a for loop to find the first one to last one. You can use maybe the same for loop or a different for loop to count zeros. But as you can see, you can also just use some built-in functions, and it will be fairly concise, right? All right, accepted as well. Yes. Going all the way. All right, let's go to the next problem. Yeah, it's also a bit lengthy, so let's resize. We have 2 matrices of the same size. Each element of A is 0 or 1, or each element of B is 0. And we may perform some operations with B. We choose any submatrix of B, which is size 2 times 2, and replace all the elements with 1. This is the formal definition. And we want to make B equal to A. And the question is if it's possible to make them equal, and then come up with a sequence of operations that achieves that, if it's possible. All right, so this is kind of like the stamps, I don't know, problem. Like we have a stamp of size 2 times 2, and we can stamp it somewhere on matrix B, and we want to make it equal to A. And since we don't need to minimize the number of operations, we can just make an operation in every position where we can do that. So we just take any 2 times 2 submatrix in A. If it contains all ones, we can just make an operation, like here, in position 1, 1, position 1, 2, and position 2, 2. And after that, we just compare A and B. And if they are equal, then we have achieved our goal. Otherwise, we print -1 in this case. All right, let's implement that. So we have the sizes of the matrix. Yeah, it should be read ints, but we have 2 ints. And now we have the matrix itself. Let's make it a list of size n. And we can just initialize each element of the list with a list of integers read from input. So this is pretty short. We can just read the matrix this way. And now let's also create B. It will be a list of lists again, but we will need to change it. So we can define mutable list of size n, size m, 0. All right, and we will also need a sequence of operations. Well, for example, we can define a class. Basically, you can also use pair, which is available in Kotlin. but we can just use, I know, step, which will have I and j. And we will have a result, which will be some mutable list of steps. OK? So, and now let's just check all possible 2 times 2 submatrices. So, for example, we can go from 0 to n minus 2, right? From 0 to m minus 2. Now we have to check if this submatrix is good. What does it mean? If all the elements are ones. In this case, we add a new step at ij, and we also change the corresponding values in b. You can probably make a for loop here, but 4 lines, so it's not really needed. OK, so if a is not equal to b in the end, we can just compare with not equal. We just print -1. Otherwise, we print the size of the result, and we print the operations. So we just join to string them. We don't have to. We can just iterate over them, but you can also join to string with \n as a delimiter. And we also, again, need to transform each pair into a string. So it will be I, again, +1, because we need one indexing, and +1 here. OK, let's try. All right, passes the local tests. Let's submit. And let's proceed to the next problem. And this will be probably the last problem because of our limited time, but let's take a look at it anyway. This problem is interactive. What it means, I guess most of you know, obviously, but anyway, in just given some input and you print some output, and in interactive problems, you do that multiple times. You read some input, you print some output, then again you read some more input, and so on. So you just interact with the testing system. We have an integer x picked by the judges in these ranges, and you have to guess that number. And you can make at most 2 queries. OK? And each query should consist of 100 integers. And in response to our query, the judge will pick one of these 100 integers and tell us the value of exclusive OR of one of our 100 integers and the secret integer. And we also need all the 200 integers to be distinct. And we need to guess the number, right? OK, let's take a look at f. OK, f accepted, good. Our integer is not greater than 2 to 14 minus 1, so it means that it consists of 14 bits, right? How can we extract some information from the testing system? Like, the actual problem is that we have to give 100 integers, and we will be given the XOR with some one of them. We will not be able to tell with which one, so it's hard to just find the result value, because, like the secret value, I mean, because we have at least 100 candidates, right? But let's see. For example, if our number is small, like, for example, 1, if we provide an integer 1, x XOR 1 will be kind of close to x, right? So let's see, for example, if we just provide integers from 1 to 100, then the result will be x XOR 1 or x XOR 2 or x XOR 100 or anything in the middle, but the highest 7 bits of the result we will be given will match the 7 bits from x. And this way we can extract the highest 7 bits from x. And we have 2 queries, and we have extracted half of the bits. So now let's just do the same, but with the lower bits. If we provide integers 1 to 100 multiplied by 128, which is 2 to the power of 7, we will be able to get the lowest 7 bits of the result. And we will form the secret value from these 2 queries. So we'll need exactly 2 queries. Yeah, let's implement this. Yeah, so the interaction format, we have to print a question mark followed by exactly 100 integers, and not 3. All right. So we just print question mark, and we have to follow it with, OK, in the first query, we want to print integers from 1 to 100. Let's just have a range from 1 to 100. And yeah, just join it to string, I suppose. And print ln automatically flushes the output, so we don't need to make any extra flush statements. Now we can read the first integer given to us by the interactor. OK, now we want to make the second query. We need integers from 1 to 100, but multiplied by, like shifted by 7 bits. So we can, again, have, oh, a bit too much. These hints are, of course, can be turned off if you get too annoyed. Or if you have a larger screen, you will probably not have a problem. But here we have big font for you to see. So we can just map all the integers to shift them by 7. Basically, this is just how you do it. You just map all the integers into the same value, shifted by 7. And again, we just join them to string. And now we read the second value we are given. And we just need to take the highest 7 bits of A and the lowest 7 bits of B. So how do we take the highest 7 bits of A? For example, we can just shift A to the right by 7 and then to the left by 7. So you just shift and then get back, and you erase the lowest 7 bits. And for the lowest 7 bits of B, we just end it with 1 to 7 minus 1, right? And we print x. Not just x, we print exclamation mark x. All right. We can run local tests, but it would not make much sense because we cannot know what input we will be given by the system. We get incorrect. We can compare outputs, but that's not really useful in this case. In any case, like again, it's a bit difficult test, but it's just the property of interactive problems in general. But we can probably just, oh yeah, it's already running. We can just type some integers here and see that at least the protocol is what we expect. And, you know, just submit. All right. Yeah, that was it. I guess we will not take, there are 2 more problems, but they are probably harder than these ones. And that's all I have for today. So once again, thanks all for your attention, and I hope to see you in Kotlin Heroes 8.
Thank you, Gena. And one more technical announcement. Timirlan Amangildin, or those who know Timirlan, please tell him to come to the host desk at front entrance. This is extremely important. Once again, Timirlan Amangildin. Thank you very much. Yeah, that's it for now. And a very warm welcome to our next global partner, global sponsor, Huawei. And let's imagine a world where you have just one championship for solving all the problems connected with the main tasks of humanity. Obviously, there can be no competition. There will be just one global team containing the programmers from all over the world, and of course it will be open sourced. And how to save the world with open source? Vladimir Rubenov, CTO at Huawei Russia, please. A very warm welcome from you. Thank you. Yes, and I will find the clicker. Just give me a second. Here it is. Good.
Okay, colleagues, I'm happy to see the brightest minds of the software world. And today, we really need to talk about things that matter globally. I might assume that you might have two thoughts when looking at the title of this talk. That it is something that you already know. Yes, most of you really know in general what open source is, and you might think that it's not too important for you now. But believe me, this topic will be important for you with some time, because it's inevitable that open source will be the major model of software development in the whole world. And let's talk about it. Yes, we start with really simple things. And this slide you really should know before. But interesting thing, that open source, you might face some open source with specific licenses. But did you know that actually there are more than 100 different open source licenses in the world? And there is actually a formal definition of what open source is. It is defined by Open Source Initiative. It includes 10 criteria, but most important are the first 3 underlined here, about that it should be, the code should be open and you can actually modify it. Also important idea here that all these varieties of licenses, these 114 licenses match these 10 criteria, so they are all formal open source, but they vary slightly. And I suggest you to remember that actually there are 2 major classes of open source licenses. The first class is permissive, which is really free license. It's most simple of permissive licenses are just, okay, you can take the code and do what you want to do with it, no matter what. You can close it, you can create commercial products based on this, no question. And the famous second class of open source is copyleft licenses. They are more restrictive, and basically they require that if you take open source, you cannot close it. So if you continue developing it or modifying it, you have to keep it open source and move further. Actually, all types of open source licenses are useful for different purposes. This is the idea of this slide. Okay, and this is the overall statistic of the current state of the art in open source world. You can see that actually there are more than 500 of open source projects in the world globally, and that count as much as 30 billion lines of code. It's a huge amount, and if you convert it to money, it will be billions and billions of dollars that were spent to create this code. And you know, here are our brothers, 5 million of open source developers in the world, and I hope that you are also among of them, or if not yet, will be there definitely. Okay, here is the secret slide, actually. This is the uncapped schema of how open source actually works. Because it's typical idea that open source is being run by some enthusiasts who do this open source coding in their free time. Yes, it is, but it's just a very minor aspect of the whole open source picture. Actually, open source is funded by a lot of different companies. And of course, there are big, major corporations, worldwide corporations that sponsor open source development in various aspects. Also, in each country, actually, there are a lot of local businesses that use open source as the basic model for doing their business, local business. So they actually create local products derived from global open source. They customize them for local market and actually make business out of them. Maybe some of you will be founders of such companies that will be based on open source business model. And I need to mention the global international associations and consortiums that actually help to create neutral platforms for collaborating of different companies together on open source projects. And interesting idea, open source allows to get benefits even for cooperating between competing companies. So actually, open source is the area where very, very strong competitors come together, do something jointly, and get benefits. This is one of the major magics of the open source. And on the right, you can see the 6 interesting points about open source. The first thing that it is really assumes in you cannot take open source out of somebody even if you are the author. You cannot say those whom you gave open source, hey, give me it back. Not possible. The world owns it. You cannot step back and say, oh, I want to close my code. Of course, you can close new versions of your products, but you cannot take back anything that you gave to open source. And it is especially important even at global level for governments. For example, open source-based products are sanction-proof. So if you use some open source-based product, this product cannot be an object of some sanctions or any political games. This is really freedom zone without any politics. Also, open source also always assumes physical availability of source code. And so the first point about some legal sustainability of open source, and the second point about technical and physical sustainability of open source. Always to use open source because nobody can take it out of you. The third point, very interesting, about actually open source now is the environment to grow world-class talents in software. This is the area that all of you, I hope, can use to get immersed into the leading-edge software development environment, where you can learn a lot for yourself. And learning something in projects, in real-world projects, means not only looking at it also involves looking how people interact in projects, in open projects, how the whole infrastructure of the projects works. So it's not only about code, it's also about processes, culture, actually human interactions. It's very huge area that you need to learn in order to become professionals. Because, just being able to write code, even very fast, even very smart, is not enough to be a software professional. You need to learn a lot of other things. Okay, let's speed up a bit. Number 5, actually, for global economics, open source is something where Okay, assume, take like 10 of you, you come together, each invest $1, do something on this joint fund, but the result is fully available to each of you. So you invest $1, but you get result for $10 or even $2. Or actually there are some synergy effects that can multiply your investments by many, many orders of magnitude. This is also one of the magics. And number 6, I guess it's especially interesting to mention this in this multinational environment, that open source is the area where multiple cultures meet. And they meet to exchange, to enrich each other. So this is like global polyphenation, like in plants, bees growing from one flower to another flower. And this is the global area where different views, different nations, you know, each nation has some unique values. And open source allows to unite those values of different corporations, different nations, different governments, different personalities, and unite to create highest level of creativity, because multiple views produce highest level of creativity, because when you are working in some environment, your creativity will be limited by definition, believe me. And the wider you look, becomes the main driver. Then you started as user, so you just download code, it's free, you start using it. Then you start to change and adjust it to your needs and contribute back. And the final stage of this evolution, that you create something new first, something unique, and you open it to the whole world, and you become the author of new open source projects. Let's look at some statistics of the most famous open source projects in the world. It's Linux kernel. And I'm talking only about kernel, not whole Linux distribution. So, you know, Linux started in 1991 with just 10K lines of code. Now Linux kernel counts more than 28 million lines of code with 450 different companies collaborating in order to develop this Linux kernel. And believe me, among these 450 companies, there are a lot of competitors, but they still work together because they all get some benefits and profits from this cooperation. Okay, and in terms of people, there are more than 400 people working on Linux kernel from around all the world. From different places in the world, people work together to develop new versions of Linux kernel. Yeah, and there are more than 80,000 of commits each year happening. And people communicate. There are more than 400,000 messages each year exchanged to discuss different technical aspects of the Linux kernel development. And here's the top list, top 10 companies who are contributing to the Linux kernel now. Yeah, and this list actually changing from version to version, it's changing. Yeah, and you can see the current snapshot of those top companies, top 10 companies from those 5. Okay, now some things. Actually, you don't need to look into detailed lines of this, but this is joint scientific analysis. What are the benefits of open sources for companies, for businesses? Because, sooner or later you will work at some companies or found your own companies. So yourself, okay, why as a business I should open my code? Okay, there are 33 points identified by different researchers why you, by the way, sorry, it was really bothering me. 33 reasons why you should open source some of your projects to get commercial and other values out of it. So we will not dive into details now, but I hope these slides will be available for you later so you can analyze if you want. Yes, of course, open source, and from the business point of view, has also some risks. So it's not like straightforward that you need to open source everything from your business, but it's really a complex scientific subject to decide what to open source and when. There are even terms like over open sourcing and under open sourcing. Over open sourcing means that you open sourced too early or too much something, and you lost some of your business things. And under open sources means that you open sourced something from your internal developments too late or not in full. So there is always some optimal point when you need to open source your technology in the right amount and at the right time. And this is really about business and money and connections. So yeah, you might want to write a program someday. I hope it can be a task for ICPC finals at some year to find this optimum given specific conditions. Okay, this is a kind of philosophical slide, but I want to share with you. Some of the concepts from this slide might be not clear for you because, you know, I had a dinner with Professor Boucher yesterday, and we discussed a lot of very fine, how to say, high-level things. And yeah, Professor told, okay, Vladimir, these things usually can be understood only over 35 age. Yes, so the higher levels of this development spiral can be understood maybe when you become, with years. But you can remember now that open source is not just technical or some organizational thing. Open source creation and how to say extension to the whole world matches the really internal nature of the whole humanity development. Yes, there is a theory, a modern model of fundamental laws for evolutionary development of individuals. We all grow through such spirals during our life. So we all start at the first level when we are interested in only in food and mother's milk. Yes, and then we grow and our values become span more and more scope. And at the high levels, you are really interested in how the world works. You don't fight for some specific company or some specific country. You are really at some top level become interested that the whole planet, that every human on this planet lives happily throughout their lives. Okay, I hope we all will be there with time, so we will care about the whole world. And open source helps this a lot. So the emergence of open source model and the phenomenon of open source really matches this evolutionary theory of the whole humanity development. Okay, and finally I need to share something about how open source relates with Huawei, because I represent Huawei here. And of course, open source has become a part of Huawei strategy. So a lot of things Huawei recognizes open source, respects it, contributes both to existing major open source projects and creates own open source projects. Actually, yes, there are examples of the projects that were originally created as closed IP rights inside Huawei, and then Huawei decided to open it to the whole world. And actually, there are a lot of, I guess there are also billions of dollars of investment in this code, which now becomes fully open and to benefit the whole world. Yes, and here is the Huawei membership in different open source organizations. Yes, so Huawei sponsors, contributes its own developers to open source, and in many ways tries to help the world become a safer place where developers and different companies can work together and do something jointly. Well, guys, we came to conclusions, and the number one point, actually, it's a summary of those mind maps that I showed before with 33 reasons to open source, and you can see that these reasons actually can be summarized at 6 major points. So when you, as a owner of company or top manager of the company, make a decision to open source, you do it why? Okay, you get some economic benefits, you enable better engineering practices and project team structures by making your projects open. You improve company reputation, influence, and recognition, and trust, actually. I missed one word here, trust. When you develop some products which are open source and are open to everybody in the world to inspect, to see what's inside, it helps to earn companies' trust. Okay, by open sources you can get some strategic business advantages like building ecosystems, etc. And for modern, I hope, for all companies in the world, there is a part of the mission from the higher levels of those spiral development model, which share some higher values targeted to benefit the whole humanity, not only single company. Because you know, if one company will target only on its egoistic targets, such companies cannot be successful in the modern world. This is some new idea might be for some of you, but it is. In order to be successful, you need to cooperate globally, and you need to think in your company mission about some higher levels values. Otherwise, it does not work. Okay, and open source is the perfect mechanism to implement this. Okay, and the last point here is about contributing to the whole humanity development and global social welfare. This is, correlates to the previous point, but it is about working on something that benefits all the world. This is what we are talking about, and that's why I'm here to share this with you, to join this effort. Okay, of course, due to these factors, open source is adopted by the, I think most of the leading IT companies use open source to some extent. And some companies actually almost fully open source based, as I told. Yes, because this approach is a win-win. Yeah, open source, by the way, I didn't talk about one of the major points about open source. It's win-win. It's when both cooperating parties win. It's not like some party win, but others lose. No, it's about winning for everybody. Tatiana told that in open source competition, global competition, there is the only team in the world, and this team fights to address global humanity challenges. So we are in the same boat as members of the whole humanity when we are talking about open source. So when you contribute to open source, you really help to save the world. This is one of the messages that I hope you will get out of this talk. Okay, and number 3 is also a bit mindset changing for someone. Because the old model was that, okay, everything that I developed should be my secret, and it's my competitive advantage, and it should be patented, etc., etc. Yes, for some areas in the current business environment, it is still true. But there are more and more areas where this old approach does not work anymore. The world is changing, and it's changing towards more and more open source fields. Okay, so from the point of company, if you don't open source your technologies now in more and more areas, you lose your business competition. Okay, guys, this is all I want to tell with you. You can find my contacts by this link. It's easy to remember by just my name. And you can, freely connect with me at LinkedIn or drop me a message in email to discuss, because personally, with open source for more than 20 years, yes, and it's really amazing journey, because each year I discover something about open source phenomenon, something new about open source phenomenon, and it's amazing, believe me. And I invite all of you to join this wonderful journey. Join open source and be the only and the one team of the whole world. Thank you.
Thank you. And by a strange coincidence, my neighbors were working in Huawei over there. Raise your hand, guys. Who is working at Huawei? Yay!
Okay. Hello, colleagues.
Yeah, just a little bit of interaction. Thank you, Vladimir. Can I have this one? Yeah. And
We are not answering any questions.
if you have any questions, because I didn't receive any questions on the Telegram.
We have 2 minutes.
Yeah, we have 2 minutes. If we have somebody brave in here with a question, I can ask for a mic. Yes, please, can we have a mic? I will do it myself. Good, thank you. And thank you very much.
Hello? Okay, it's working. Thank you for your talk. My question is, what would you say is the main difference or main advantage of open source against the free software movement of Richard Stallman?
Okay, I can see the same actually in the sport as I told. I think open source source by open source initiative definition, and the free software as defined by Richard Stallman, they are essentially about the same phenomenon for me. So I respect, I met with Stallman someday, and we are a part of open source initiative, so I know everybody personally. And actually there is no conflict. Oh, by the way, those 114 licenses, open source licenses, that match OSI criteria, also recognized by Richard Stallman. So there is no conflict anymore between these two systems.
Good. Anyone else? We just have 1 minute left, so one more question, maybe from this side. Yeah? No? No. Okay. Sure? Just one last chance? No. Then a warm applause for Vladimir once again.
Okay. Thank you, Colin.
Thank you. Okay, guys. This is a tradition. I'm starting with the technical issue once again. But okay, teams 1 to 60, raise your hands. That's it? 1 to 60. From 1 to 60. Yeah, okay. You are having your lunch from 12 to 1 downstairs. There will be no additional announcement, just this one. Teams 61 to 190, raise your hands. Wow, you are having your lunch from 1 to 2, 1 p.m. to 2 p.m. There will be no additional announcement, again downstairs. Just the last question. Who has ever played Call of Duty? Raise your hands. Not that much. Call of Duty Black Ops. Okay, who have ever heard about Call of Duty Black Ops? Raise your hands. Good, then I will cut it short. Dave Anthony, the CEO of the Deviation Games, who is profoundly known by his active part in the development of Call of Duty Black Ops, with a very warm welcome for you guys.
Hey there, how you doing? I'm Dave Anthony. I'm the CEO of Deviation Games. First, I'd just like to say a huge thank you to Jeff and the entire ICPC Foundation for including Deviation Games as part of this just incredible competition. This is just so cool. I'm genuinely excited to be here and to welcome all of you to the ICPC World Finals. Look, I've got to tell you, I'm a former software engineer. I was absolutely terrible, actually, but I would never have stood a chance to get here. So I have massive respect for you guys. And that's exactly why Deviation Games actually is so proud to be a part of the ICPC community. We did the Gaming AI Challenge back in June, and we were just blown away by the ingenuity and passion of all the competitors in this competition. And we really look forward to getting to know you all better in the future here. So let me tell you, ICPC really means something to us actually at Deviation Games. Because guess what? It brings together a global community of like-minded developers who are the best at their craft. That's exactly the same principle as why my partner here at Deviation Games, Jason Blundell, and I, that's why we created Deviation Games, to create a home for the most talented developers in the world where you can make games and just have fun making them. That's our mission. And game developers, we've always been on the bleeding edge of creativity and the technology that brings that creativity to life. And it's that marriage of creativity and technology that makes literally anything possible. That's why I love building video games. And I'm sure that same spark is just on fire in you guys. And I want to encourage you, no matter what happens at the outcome of today's contest, just keep striving, keep pushing the envelope, keep challenging yourselves, and always think outside the box. Always think what if, and keep that spirit of fun alive inside you. Because if you genuinely love what you do, you are always going to do your best work. So I just can't wait to see what you guys come up with and the creative ways that you solve this challenge. I hope you all have a great time in beautiful Moscow, and I wish you the very best of luck during the World Finals. Cheers.
Yes, and in a short while, I think I will make another announcement, but you are all warmly welcomed upstairs on the balcony for the registration, for some drinks, eatings, etc. And there will be still another one from all our partners right now. So yeah, I guess it will be around 10 to 30 minutes. Take a look, or if you need to, go upstairs, downstairs, and come back.
四山洞拐至下顺线广州市场走。
Programma que tiene una arritmia leve.
My name is Ruslan, and I have been an intern with IBM Quantum this summer.
My name is Yeva. My research at IBM focused on studying important reactions using quantum computers.
Hi, my name is Rachel Lee, and I'm currently a sophomore at Harvard studying computer science and statistics.
I'm Ramnik Tota, and I'm here to talk about my IBM Quantum internship experience.
Going for an internship at IBM Quantum was a no-brainer for me.
Implementing configuration management functionalities to the QTracker tool.
I knew very less about quantum computing, and I just wanted to give it a try.
At summer school, I learned so much about quantum computing that I hadn't known before, and it was just definitely a deep dive into theory, helping me to learn more about the complex math that underlies quantum computing and all the technical details that go into creating quantum circuits and quantum hardware.
It looked encouraging for me to apply, to work with IBM Quantum, and I am humbled to have had this opportunity.
It's a world-class science, and it's done by world-class groups.
This internship has definitely changed my future plans.
I realized that IBM offers this really great and unique space for people to research, and so I'm definitely also really excited to explore that as a potential career option in the future as well.
My name is Teja Sachdeva. I'm a recent graduate from CSU Channel Islands. Ever since I've been a kid, I've always been into technology. I've kind of been the person around the house who's always fixing things, playing with gadgets. So that's always been an interest of mine in technology. And when it came time for me to choose a major in college, computer science was the one. My professor actually told me about AWS Educate and how he was using the platform to teach students about cloud computing. So that was really exciting for me, and that's where my journey started with AWS Educate. It was like a cloud computing 101 course for me. None of my classes in college were really about cloud computing, so I wanted to see what it was about, how it's being used in the industry, and what are the career aspects of it. 90% of companies use some aspect of the cloud. That is huge. I can take the skills that I learned here and apply them anywhere. As soon as I got exposed to AWS Educate and I got my cloud practitioner certification, it exposed me to so many different opportunities, both job-related and networking opportunities, which in the end led me to this great position at AWS Educate. I'm currently the program manager intern on the AWS Educate employer team, so my task is to mainly help students get employed. Having gone through the AWS Educate program has put me in the perfect position to help future students because I was in their shoes not just a few months ago. Working on the Educate employer team gives me a unique lens into the program, and just in my first 6 weeks I've been able to make changes to the portal which allows a better student experience. The opportunities with AWS are endless. If you're a college student, just dive right into AWS. It's free for students. You can take the Cloud Computing 101 track and just immerse yourself in cloud computing. Don't think twice about it, just go down this road. At the end of the day, you get to learn something new, which you can apply to other areas of your life as well.
So I interned at 2 Sigma last summer, and I returned this fall primarily because of the people I met.
I feel like people here genuinely form a community around shared interests, usually a shared passion for science and tech.
Honestly speaking, finance wasn't on my list when I started job hunting. But when I came here, everyone was so smart and so friendly and so sincere. And I feel like my skill set can be truly valued here, and that's something really important to me.
There's so many cool, exciting projects to work on. I know I'm going to be working with those people that are super knowledgeable, and that's like what drives me to move forward.
At other tech companies I've worked at, you can kind of feel like you're a very, very small part of a very, very large thing, and that you're kind of expendable. Whereas here, people are extremely invested in my success.
This is just perfect. Pretty happy I made that decision.
The world is moving, day after day, year after year, over the centuries, era. It moves as long as people feel connected to each other. You cannot touch the connections, but strongly felt. Day after day, Megaphon makes these connections stronger, brighter, and more diverse, spewing innovations that instantly become part of our daily lives. Megaphon became the first operator to create a network covering more than 17 million square kilometers. This was the first way in Russia to implement 3G, LTE, and LTE Advanced, opening the era of mobile internet.
OneC Enterprise, low-code platform for rapid cloud, desktop, and mobile application development.
Дадите мне микрофон, ура! Спасибо большое. Всем опять привет, я перейду на русский язык, и если вы его понимаете...
Hi, I'm going to talk Russian now, so go to the main hall because we are going to have the most hyping topic we've ever had at ICPC. So please come down here. We're going to discuss NFT. And even Saturday in Moscow, there are traffic jams, so we will be joined by 2 more speakers. But let's start now. So I'm going to, let's do it without Bill. Okay, today is a day experimenting, and I'm expanding my horizons as the moderator, and I love it. Let's start with the following. Tatiana, you were number 2 after Mr. Aksionov, because what I expect from you is quite a tough talk as to about a bubble in NFC market for our men to follow with saying how wrong you are. So I read the interviews of Michael and Kirill and Mr. Koshylev's. I read whatever I found. So, okay, let's start with some basics. Hype. I don't like this word, but it is very pertinent here. Hype around NFT is amazing. We all hear as like Jack Dorsey selling his first tweet and 560,000 Christie's Sotheby's trading huge money around. From the point of view of investments, is it reasonable in NFT? Well, talking about hype, venture funds did create it, and I think venture industry, well, it's not the cycle of such bubbles. Venture funds are professional at that. Then it was followed by other waves, and NFT is not the first wave either. There was a wave of and I remember everybody wanted to invest and discussed cryptocurrencies, bubbles were out, and the hype was thus created. And now it has not disappeared, still there, but that's the latest hype, which attracts mostly private investors. We read the news as to horse hunting the NFT. That's not venture funds anymore. That's actually a division now, because venture funds, it means that they don't believe in it. Venture funds, looking at NFT, they see it as an instrument, and we are trying to understand where it makes sense, where it's applicable, where NFT and the mechanism of uniqueness and other types of transactions make sense. So I would draw your attention to another hype which recently is out, is Nativerse, because it's actively discussed and it was announced by all major players out there, Microsoft, and they call it differently, Omniverse, but actually that's an economic layer in the virtual world. But initially, the elements which participate in these economic layers, they are initially virtual. It can be some games elements or elements of art, like, for instance, it can be whatever. And with the account of the fact that art is created by neural networks in virtual format, and obviously virtual economy is needed, uniqueness of those objects, and you have to know how to confirm that that's exactly the object, because everyone who owns virtual objects should know that it's unique and it cannot be copied, that it's with him forever. That's NFT. Okay. Then a question, look, the cost of the price of any art object is made up of many risk factors. Reputation of the artist, galleries exhibiting, assessments or evaluations of the critics. Well, if we put a blockchain, will the risk go away? Or will it? Well, it's not about risk. It's made up of a lot of parameters. They are the bubble. So it's critics' opinions, uniqueness. It's well, actually, yes, it's well, it does drive. Well, actually, you can explain it in a way, but if you look at the cost of different skins in the games, and they sell it at hundreds of thousands of dollars, but it's just coloring the heroes or personalities in a game. But if it is unique and it was published by someone, what important here is that with like with any object, scarcity creates hype. I
was waiting for the whole of our speakers to come. And now, finally, we'll have a blessing from you, Bill. Please say a couple of words. William Poucher, the Executive Director, ICPC. And I have a question that I formulated the following way. Technology and culture. How to make a change and not just a zilch.
Oh, okay. Well, first of all, we need to have a technology that allows me to get my mask off. You know, I think I was better at getting my diaper off when I was 2 than getting my mask off now that I'm 72. But both are worn to protect the others in the community, and so I'm adhering to that. Well, first of all, beauty. Okay, if you can define it, it's just not beautiful. Beauty is experienced. And culture, I think it's a lot like beauty. It's about experience, it's life, it's seeing the rose differently than you saw the rose the last time. And what's technology? I don't know. I will tell you, I was actually in the discussion in which we defined the term computer science. And we didn't know what to call ourselves. And one person said it should be computing science. And another said it should be computer science. And said, yeah, but a computer, that's like calling an artist a brush scientist because they use a brush, right? And then another one, me, said, well, okay, why not computics? You have mathematics, you have physics, okay? And then someone says, yeah, but it's not like we're trying to produce a number, we're trying to produce an experience, a process. It's about life, it's about structure, it's about institutionalizing something that you can rely on and experience and all of this kind of thing. And then somebody in the back said, okay, let's just call it computer science because that's what everybody calls it. Okay, all right. Well, you know, this is the way that language works for us. Sometimes something just needs to have a name. And I like the name Caltech. Well, why? Well, because it's a matter of making a statement that the dawn of the digital millennium is here. Okay? And Caltech is really about the notion of culture, the expression of the souls individually and together, okay, working in the life of people. And technology providing that infrastructure, you see. But when I look out at technology, what I actually see are artists. I see performers. That's why you have the ICPC, because it's not enough to understand what it is. Somebody has to do the art. Now, if somebody's going to do the art, somebody has to create the culture, okay? The institutions, the organizations that feed that human process, because that's how humanity works. We invent and reinvent ourselves in every generation. And so one of the things that I really love about the digital millennium is that we, computer scientists, inherited everything from every discipline you could ever imagine, from music, okay, from physics, from mathematics. It was all there for us to absorb and to use this new media to invent new ways of doing things. And we're giving back. Because one of the biggest challenges that we run into is acknowledgement. You see, we souls like to be acknowledged. We like it when somebody thanks us for doing something. And what does blockchain allow you to do? Well, blockchain allows you to have a rigorous algorithmic way of documenting the thank yous of creation. And that is very, very cool. Now, the other thing is that we thank people in a lot of different ways. One is through acknowledgement. Another one is through investment. You see, one of the interesting inventions of humanity is this idea of property. Sometimes it helps, sometimes it doesn't help, but the bottom line is that societies that don't have a notion of property fail. They just fail. So we have to adjust from time to time the notion of property, you see, because property sort of invents this notion of value, okay? And it invents processes for investment, making sure that nutrient goes where nutrient needs to be, you see? And so what I see that is happening with the discussion about Caltech is not only the creation of new media, new ways for people to express themselves, new forms of art, but the need to build institutional and organizational processes that keeps it healthy, keeps it available, keeps it affordable, and most of all, keeps it. Because you see, great art is lost every day. But just maybe, with the technologies that we have, we can preserve the expressions of souls in the past and allow them to merge with souls in the present for thousands of years rather than tens of years and 20s of years and 50s of years. Now,
Bill, I'm sorry, but
I thank you very much for you allowing me to have a few words. That's probably 10 times as many words as you expected. But let me turn it over, and I want to hear what you all have cooked up for us. And all of you out there who, you know, have ears, understand that all people get together who have different perspectives of the world and merge those, create those into a greater good. So that's it.
Good. Thank you, Bill. And some applause. Good. В двух словах. Быстренький перевод, потому что на самом деле два тезиса были...
Well, two bullet points were fantastic, very good for us. Technologies allow us, A, to preserve what we have and preserve it in a clear way and preserve it for eternity, because otherwise it would be impossible or next to impossible to do in other formats. Technologists and programmers and all those guys in IT, they're very lucky because they can collect all those disciplines inside them, any discipline from culture or physics, chemistry, whatever. And I would allow myself to phrase it. The technologies, of course, allow us to make a very important combination of physical and non-physical, which is impossible to do anywhere else. Dmitry, since you were late, you will finish. Well, we will continue with the guys, and you will have this honorable function to finish. Well, Tatiana, I will phrase for you, just to remind what we were talking about before. The first voice of Tatiana is that NFT is just a hype. But a useful one, okay? So, okay, Dmitry, let's address you. NFT, what is that? Useful, hype, a bubble, not a bubble? Are you ready to invest in NFT? Or maybe you have bought something already? No? You don't? Okay. Thank you. NFT in the recent 6 months actively. So in my perspective, it's a hype, of course. And then ownership. Well, as art dealer, art be about mastering, about mastership, and everybody was masters to reflect or depict horses or whatever. Then revolution came as avant-garde, who said, they said, it doesn't matter what you express, it's how. Then this idea started to dominate in art. There were some other sub-ideas, sub-clusters, but then NFT comes down, saying that it doesn't matter about idea or mastership. The most important thing is who owns it. If I own it, it's in my pocket. It's in my phone, it's in all the gadgets, and that's a hype. And that's a new story for me. Of course, it's all well prepared by Sotheby's and Christie's and all those auction houses who, for more than 50 years, been inflating this bubble of modern art after war. But that's a logical finishing for me. It doesn't matter what I own. What matters is that I do own. Well, that's a hype. And for me, it's a story about NFT, the NFT. As for how it's going to develop and evolve, I think that the society and culture will try to reflect on that philosophically, and that's exactly what we are going to do. During the exhibition of NFT in Hermitage, we're going to show not just pictures or works which are funny to us, or some are about gaming, cats, kittens, or whatever. We're trying to understand how it is relevant for culture and what it means for culture, what NFT can do, other forms of art cannot. What NFT can do for the society, and how it can serve the society, and how it can be used. Well, that's quite a trivial question, but I do apply it as to how we can use a picture, a painting. You can decorate a wall. And what can you do with NFT? How can it serve? So that's exactly what we are going to talk about during our exhibition. Okay, all invited to Hermitage, and my Facebook is full of messages that it's time to buy an apartment in St. Petersburg, when after Hermitage exhibits again something.
Need a translation in English. We have special gadgets and devices that can allow you to understand what we're talking about. На русском перевожу. Я только что сказала, что если кто...
So if someone wants to join in, we have great devices to help you out. Misha, I would like to switch on you, because you as an artist, well, your phrase was a phrase of genius, and I read your interviews. I loved it. Your quotation, for me, it sort of crossed the I's and dotted T's. So the digital format of art, first of all, is an experiment, and the real art is exactly about this. So NFT, do you think it's just real art? Yeah, good phrase. Good phrase. Great. Well, for me, yes. In my understanding as an artist, art is exactly about experimenting. Well, clear enough that there are some other classical, maybe, approaches to that. And in this case, you can talk about two things in NFT. One story is about financial part, cryptocurrency, and that's a big part of NFT. And another part, which is about experimenting with digital art. That's not new, of course, in modern art. Digital is not new. Digital met art, and there were different approaches in the recent 15 to 20 years. But what I saw in that is some new approach, because the big mass of a big community And in my work, it was interesting. It seemed to me that through this, you can try different experiments, new technologies and new technique, and new fields, so to say. Moreover, since there's a certain community. I was curious because I did a lot of collaborations of artists with artists who are in motion designs or 3D graphics, digital arts, and they've never been thinking about any exhibitions. They were located in their design bureaus. So I did collaborations with artists who know the technology better, and we were inventing stories. It can be video or a static picture or a GIF or that's exactly the experiment, to collaborate with people you never worked before with. But I'm always for collaboration. It's difficult, of course, but with digital artists, well, I've succeeded. With painters, it would be more difficult. If, for instance, we sit down together to make a canvas, well, it would be more difficult. Another question. In May, all cultural mass media were writing that Misha Most will exhibit at NFT marketplace in Binance. What about that? What about this cooperation? Yes, Binance was launching a platform, 100 artists in the world, 3 slots for Russia. We have reps of NFT Arc, it's a producer agency. It was Pokras and me. There were 3 of us from Russia. So it did happen, yes. And I even sold some of the works. Some are still on sale. I'm adding some of them, and there's a pool now open, and we have more artists in them now. And every 2 weeks they open up something additional. So that's quite a powerful platform, and so they did succeed. So yesterday I looked up the website, and there's a huge collection of working sort of monkeys. Well, just like at any other platforms, but percentage or interest relationships different, but quite successful. It was interesting for me because I had experimented with other artists, and that was good collaboration. Kirill, let's check. Maybe your mic is okay. Great, super. Instigators, translated as instigators. You are instigating or artists for NFT. And the quotation from your manifesto, we are conductors to the blockchain art, which only at first glance is easily penetratable. Why, at first glance, why do you believe in digital art so much? And so the main buyers of NFT art, who are they? Are they cryptomaniacs or good investors? Well, first of all, please use microphones closer for us to hear. Okay, let's start from the end, from the buyers. NFT buyers are very different people. Misha was discussing the Binance platform, and I would say that one of the main advantages of the platform is that Binance is #1, not directly in the blockchain where you can buy NFT. Quite a curious thing. And NFT buyers currently are absolutely different layers of population. And the producers of NFT are absolutely different authors from just everywhere. Well, now closer to instigators and role.
Instigators is acting as... Actually, NFT works in the crossroads. Speaking about art and culture, works in crossroads of computer technologies, blockchain technologies. It works in, it turns it into a new medium, and the capabilities of it is not always known to people who are not really aware. You know, 10, 20 years, the digital art experiments were underway, and one of the problems for such art is that authorship can be recognized, but ownership not. Because any picture on the internet, you can just download it and download it with a one click of a mouse. But will it be an original artwork? What is the provenance? Who owns it? Many things like that are realized are solved through NFT. And question you ask to other people, other speakers, what is NFTs? The hype, NFT is an instrument, and it will stay as such. And it is a brush and a piece of paper and the same level of instrument. Many artists are interested, and it is something unique for them to collaborate with creative specialists, specialists in a creative approach. And this widens the horizons for those working on the technical part of it and artists, those who carry the ideas. Since those carriers of ideas get a wider range of instruments to express themselves, the idea today in art is supreme, and the more opportunities to implement it is better. But instrument for whom? For artists or for investors? To understand the provenance, actually, or it goes both ways. Actually, both ways, it is a basis for transparent relations, and that's very important. Super, let's ask artists. Let's start with Kola. Kola, thank you very much for making it here today. The question is why, but the correlation is obvious. You have your joint project exported from museum, a 3D technology. Two of your artworks were articulated. What is the proper word for them? Yes, they were articulated basing on the objects that sit in the Tretyakov gallery at that point of time. Well, we cannot say printed, okay, fine, articulated, formulated. There is a good point, and many people mentioned your campaign, but in vc.ru, I like how the guys wrote about it. It's time to free up artworks from museum halls and launch them and let them go into the free digital world. Is it the idea you are thinking of, or it's something different? As an artist, could you please tell us what is NFT for you? All speakers so far, except for Misha, we are theorists mostly, not practitioners. A very good question, because I had 3 stages, seriously, 3 stages. I first fully neglected. I could not accept it. I just came from the mounting session to Moscow, and the guys told me, let's meet, we will show you something. They show me these cats and CryptoPunks. I said, guys, are you serious? Well, this is cool, but I had the same thing in my Nokia long ago. I didn't understand it. So first I called my director. I said, Lisa, let's meet. I show her Miley Cyrus dancing pictures and all that, and she was also crazy about that. But I was just interested in it as a phenomenon and how it works. And then we started talking a lot about maths, about structure, and then guys told me how they are working in this. And what Kirill mentioned about transparency, you can have a look at what it is all about, the provenance of it, and go into the collections, what people are interested about. So this is a slight interest that emerges in you, as if they always tell you, let's just watch the Game of Thrones. And I never watched it before, and then you start watching it and you understand that yes, this is a thing. And that was season 1, season 2. But when we started, and when guys came to me and told me how it can be, and when they showed me the visual capabilities of programming, and we created the story in just one morning. The mounting started, but we realized that no one did this before. Why not dropping it during the project into a different world? Those are not digitalized copies. We created them from scratch. We took two very important objects, very important for me, visual communication objects for this program, and we selected one iconic thing. We reworked it, and 17 people worked on the texture of it. We wrote new algorithms, and in the code there is an extension that extending it into NFT allows you as a collectioner to have it screened through your projector on a 5-story building. So the resolution capabilities is just amazing. This is not NFT for me. This is just a format I'm giving away part of the project. And a question from a not very experienced person. So do you have programmers around you and you redid all that? We had a chat for 44 people, just for one rotating picture, and I was very nervous about the project, even more than when we just did not do work properly, and I ruined my 6 works in a furnace. Sounds great. And will you exhibit? Have you exhibited? Have you sold it? The first drop is sold out. We are preparing the second drop now. We met Kirill in a restaurant. We had our shashlik and meat barbecue, and we created a second drop, You should not think of pictures. This is project thinking, and it takes long in production. We are not in a hurry. This should make you happy. Just a couple of things. How digital impacted me as an artist. After we developed the textures, and after the exhibition, for instance, what I have, photos, photo reports and feelings, impressions, photos from exhibition, and technically I should look at a PDF and have a look at things. But here I have this beautiful thing. I know how it was produced. I like it. I open it, and it really makes me happy. And this is not archiving things through photo cameras, through PDF and the vision of a photographer. No, it is the real thing, and if I'm on a plane, there is no internet, but I can show it. But, PDFs are not available. Yes, I read somewhere that you can make your work eternal as an artist. It's hard to say now, but I like the technical capabilities that we're enjoying now in the world, and it's great that it impacted me in my standard practice. Max, a question to you. NFT agency ARCA, NFT Busters Association. We should speak about Brickspacer also. He is super famous for this. From your point of view, from your perspective, why you like NFT, why you see that there is future for it. And another point I would like you to think about, this is a really interesting thing. I will ask all of you this question, but how can we differentiate real NFT art from not real NFT art? Like it was in our Nokias 10 years ago. Obviously, modern art is hard to assess, but if we put it into NFT, it gets even more complicated. But yes, there are some crappy things around. Well, I should say that there are grades. It's an absolutely formal system, because to grade art for real and unreal and stupid, it's not the right thing to do. Creativity is about something different. If we analyze it, there are authors with background before NFT, and they go to NFT and they sell very well because they're very successful artists in offline, like Koля and Misha. Yes, absolutely. Misha is superstar. And there are new people, newcomers, CJ artists who worked in the tech part of this thing, and they had ideas on how to show their philosophy, their ideas, and they went to the NFT market to create content, art. And in order to understand whether the art is valuable or not, you should look at its philosophy and at who actually stands behind this art. Because there are cases where artists with guys on Instagram make huge sales comparing against the market. And if we understand the average statistics in sales, then the prices they have for their art are quite high. And it all depends not on how famous you are in the media, but how well you are communicating with other people. Because NFT community is about communication of creators and collectioners. And in cases when not very famous artists find their collectioners and sell their art with high prices, they meet each other almost every day. And I think so far there are no strict boundaries in terms of volume of sales among various artists, famous and not very much famous, but everyone can find their buyers. But in your Telegram channel, you have 15,000 people. Not that much, but actually this is a large community. The community of NFT in Russia, is it large enough? And is it a mass thing? I understand that, yes, we are here at finals of ICPC and we have super elite brains here in this room, and you're working in computer things. I understand why we're discussing all that here in this audience, but actually, how deep is the penetration of NFT in Russia? So far, NFT Busters is the largest community in the CIS in NFT and one of the largest in the world so far. Every day, in any case, people get deeper into this subject. They try to sort things out. New artists come into this market and try to sell their things. But after the first information boom, 1 year passed, and some guys were communicating with artists who only work in physical world, and on behalf of our agency, we want to be producers of them, or brands were interacting and cooperating with in terms of ad campaigns and image campaigns, image projects. They might have heard something about it, but there are mostly people around who never heard of that. Yes, 70 million sales increases, and that's all they know. Yes, another demotivating story. Just ask those who are related to NFT to explain what is blockchain, or those who are interested or are thinking about investments into NFT. What is blockchain? Dmitry? I just wanted to ask the previous question. We always think that they were all the prominent masters, artists, and now just crappy things happen. But no, bad art always existed. And there are a lot of pictures and paintings of low quality, middle quality in various galleries. And yes, there were a lot of bad things. Time preserves good things, and we forget the bad ones. But there was now this border between great old art and then just hype started, the digital era. Absolutely. So the demand creates the supply, and NFT in the digital world, NFT artists will survive if they properly structure their strategy and make very interesting things using the high-tech capabilities and moving forward. We just need to understand that, for instance, Beeple's work was sold $69 million and it was a scandal. We understand that this sits in the crypto world anyway. We're just translating it, but now the hype with the crypt growing and a lot of crypt liquidity around, and this is in wallets, and the question is how to spend it, what we should do with that. And NFT is going up with this demand. It's out there. If something happens with the cryptocurrency, then it'll also impact crypto art. And I'm saying this because NFT art today is related very much with cryptocurrency, comparing against other types of art. It is not very much impacted by currencies, crypto or not cryptocurrencies. So NFT is just a satellite of this crypto market. And the next step is when it goes independent. if it is possible. When it gets independent, it will become a phenomenon in the art world, but not yet now. Understood. Correct. Agree. I agree entirely. So, Dmitry, question to you. And by the way, it is interesting for you. NFT, it is a satellite, a good satellite, an additional element for the cryptocurrency story. Where you, as investor, take Caltech and NFC from cryptocurrency theme and look at this as an investor in terms of money, and why you're not scared? Well, please give us one hand mic. Thank you. I will answer the question you asked before. Is it hype or is it a useful hype? We thought of a useful hype and a hype and no real definition. Hype, a bubble, or fundamental changes. What is it? Hype and bubble is the same. I think, indeed, in the current time, this is a bubble because the phenomenon of selling something for 70 million is not a sustainable case. But this is a useful hype because it drew the attention of the community, of the society, not the digital community, not the crypto community, but the whole society on this to this phenomenon. Previously, real artists, in inverted commas, old masters as we call them, current old masters who are seen as successful in the real world, they first negated, as Nikolai said, saying that this is nothing, there are no ideas in it. Dmitry mentioned it, that art was about something beautiful before, but now it is about ideas. But looking at cats, kittens, or dancing monkeys, it seems like there are no ideas in this. But nevertheless, the attention was drawn to phenomenon. 70 million, this price makes you think it over. And also I was thinking it over at a point of time of the phenomenon of modern art. When I asked the question, how a person does know how to paint things, how is it possible that his works cost millions? Why? Because the society values such cultural phenomenon, and supply actually sets the price. Since supply is limited, for instance, an artist has died already, everyone wants to have this. And everything actually goes to museums, and they do not sell anything. And the remaining things in the market, the prices for such things are so high. That's why old masters' works, or even modern artists, cost tens of millions of dollars. But getting back to the phenomenon of NFT, yes, this is a useful hype, but it's here to stay. The world has changed, and we will not get back to a situation where there is no such phenomenon around. The main idea of this phenomenon is that distributed register allows the consumers and the producers in a transparent way to interact in a very informative way, in a very multifaceted way, and it creates a new form of relations between artists and consumers of art, consumers of products of art. And since we say that the main story is about ideas in art, and that's where these relations start. The creator creates something, gives it a form, and someone values it. And what is the advantage and what is the game changer here? If we say that the main value now in art is ideas, as Dmitry says, but irrespective of how you actually translate it, a digital file, an installation, a painting, or something different, this is a medium, this is an instrument anyway. But the main changes is that we are all living in the digital world now. This is a new world, and the main discussion now is whether we can be better than artificial intelligence or it'll be better than us. But nevertheless, everyone is sure they are living in a different digital era. Everything will get digital, and art is also part of the process. That's why we think that the phenomenon of Caltech, that culture and art are appropriated by technology becoming part of a global digital space, it's inevitable. So that's a useful thing. And answering to your question whether I interpret NFT as an investment instrument, of course, yes. But that's not number one. Number one is idea, evolution of ideas, technologies, and combination of real elite intellectual art and wider world of technology where the main consumers are located. So this spread is going to narrow, and we will see successful forms of cooperation, of appropriation by the old world, and the owners of technologies will upgrade. Those who are doing technologies, they will penetrate the ideas world. And since all the population is consuming digital, well, I think it's obvious. Let's do the blitz. Let's start with Nikolai. So for 2022, what will happen with NFT and with you in NFT? And if there are any plans, you can announce them here. You can publicize. If you follow someone in the NFT world and think that they can shoot next year, that would be super. Well, my subjective opinion is that this will get over to involvement format. Your involvement in a project. You will want to become a part of NFT project you like. In other words, my opinion is that I need 5 years to go from idea to final production. Well, this process is long. It doesn't matter whether it's NFT or physical. Well, NFT. Well, we are just 6 months old. We just started. So this year, my protocol Pokemon Go. That's it. Okay, Kirill. Certainly, the market, the crypto market, has quite clear-cut cycles, and I hope that next year they will change a little bit, because the attitude of the society will change to the market and those technologies. And it was said here, and it's right. It's about distributed ledger and it's accessibility, interaction among the people. It's belonging to a society. If, for instance, people enjoy the same idea or share some visual ideas, or through belonging to this community and the common vision, they would have some ideas, and it will stay. NFT will develop and develop quite rapidly, and we will fight for NFT. Tens or hundreds of different applications, much beyond culture or art, and even economy. That there will be globalization, both informationally and technologically. There will be more complicated projects at the crossroads, art and technology. As Kirill said, I think rather there will be involvement of users, more involvement of users into the projects. Michael, do you have any specific plans? You know, I wanted to add
Bill said that finance and gratitude, and I think that crypto world, belief is very important. It's important when people do believe in it, and here to stay, as was said. But something dramatic should happen for this to stop, because it's clear that this will exist on. I think it will change. I hope that there will be fewer 8-byte pictures. There will be many more serious things like format of static art, or it will get over to the formats when NFT will just confirm and be a certificate of a parallel story. I think that the format will change a little bit. It doesn't take just 1 year. I think it's several years. We will stop perceiving it as stupid pictures. I think it will change because technology will stay, but it will be more seriously applied in some parallel type art. Penetration, complication, Dmitry. NFT as a means and technology in the future, it will be used in all spheres more and more. There will be new formats, because now there are 2 formats, and I know that the developers are inventing new. NFT, I think, will aside, will try to survive on its own. Last week, I thought about NFT, but now, there was a message that those who collect arts, and they voted 50% that they wanted at Art Bazaar. So, and it means that NFT is coming, and serious collectioners will come in. So, and this means that they will require expertise, feature expertise as to how this or that artist will shoot or how he will grow. And this will lead to a necessity to creation of expertise. So we are doing it in St. Petersburg, a platform, expert platform, to deal with it. Expertise from the point of view of art in NFT field. Good niche. If someone wants to collaborate, you can look up. Well, it seems to me that, interestingly, a lot was said as to how NFT and technology per se can be used as instruments by different artists. There's another outlook as to how NFT and similar technologies allow you to include art into technological virtual world. And here, I think, it should go both ways, as instruments for artists and technological world to bring art into those developing new things. And I paid attention to the fact when we talk about virtual world, gaming, for instance, is not perceived as entertainment by new generations because it's virtual space young people spend more and more time in. And in this virtual space, there should be not only mass graphics, modern art should be present there, and art should be brought in. And I think that NFT is just an economic layer. It can change with different instruments called differently, but speaking about bringing in all elements of modern world into the virtual world, of course, there should be economic layer there, and all the respective relations and art should be in, and not only artists are we discussing today, not projects. It's different types of art which will be transformed into the virtual world. Technologies provide a lot of opportunities, collaborations, and also it was said that NFT is an economic layer which transforms and makes easier to transact. And I think that there are so many opportunities here for both technological startups, companies who can create some additional elements to bring into the world, And like Metadoors, the way it is going to be developed, a lot of opportunities. And it would be great to have more and more artists and creative people to join in, to bring in uniqueness, their ideas into this developing virtual world. So as technological investor, we are looking at whatever helps this movement. Super. Thanks, Dmitry. Just 1 minute to go to finalize the whole great abracadabra we are having here at the ICPC. NFT in its future, not far distant future, but next year. Regulation, first of all, should finally, during the year, come to some conclusions because this determines the distribution ranges. Well, since it's about technologies, the changes will be very fast. The meeting of the old and new world, and I agree with Dari, it's not only about visual, it's music, poetry, whatever. Every creative work will be implemented, and during the year we will see successful projects and ties with of old world coming into the new technologies and digital reality. We are just in a very interesting and amazing historical moment, and we just don't realize yet, but it's super amazing. It's going on now. It's underway now, and during the year it's going to be a wow thing. And Russia, interestingly, has unique opportunities because technological talent here is combined with cultural talents multiplied by creativity, which will lead us, lead Russia to be the center of gravity here. Thank you very much, everybody. Unfortunately, the time is up of our panel discussion. Thank you very much for being with us. Let's applaud. Thank you. Okay. Please leave the stage and I will continue my talk because we will try to seamlessly get rid of all those chairs and all, and I will tell you what happened before and will happen after. Today, since morning,
Yes, hello, this is Dmitry Maslov speaking. I am a chief software architect with IBM Quantum, and today I will be talking about quantum computing. Firstly, quantum computing, in a nutshell, is a computing paradigm that is based on the laws of quantum mechanics as opposed to Newtonian mechanics. As you know, all modern computers are electronic as opposed to mechanical. And the reason they're electronic is because electronic components are a lot faster at switching than mechanical components. Apart from that, regular everyday classical computers behave according to the laws of Newtonian mechanics. And quantum computing is different because it relies on quantum mechanics as an underlying physical theory of the world. Since the two physical theories of the world carry different names, this suggests that they may offer different computational capabilities, which turns out to be the case. The goal of my talk today is to prove it to you explicitly that this is indeed the case. And to this end, I will need to define what quantum computations are and show an example of a problem that can be solved more efficiently by a quantum computer than is possible by a classical computer. So let's start. When we think about the process of computation, and this is particularly relevant, I believe, to the experience of the ICPC finalists, is you need to think about a couple of things. In no particular order, One is data structure. In other words, given a problem, you need to create a data structure that exposes the features of this problem that can be explored by a known efficient algorithm to obtain the answer. And second, you need to apply this algorithm, you need to develop it, you need to code it, and apply it to the given data structure. And the algorithms can be anything such as a recursion, divide and conquer, and so forth. So likewise, quantum computation can be understood and assessed via defining the data structure and the operations that one can apply to the allowable data structure. So let's do precisely that. So firstly, the state of a quantum mechanical system with n bits, called qubits, as in quantum bits, is described by the probability distribution over all possible states. So here is an example of the set of 8 probabilities describing the 8 possible states in which a 3-bit system can reside. And 8 because 2 to the power of 3 equals 8. So it turns out that these numbers are actually complex valued, and in order to get to the probabilities, you need to square them. But apart from that, you can think of this as a probability vector. A very convenient notation for the purpose of computation in quantum is the Dirac notation. So the Dirac notation, it refers to the coordinates of the vector rather than listing the vector of size 2 to the n. And the reason Dirac notation is convenient is because oftentimes there are only a few non-zero amplitudes in this state vector, in other words, non-zero alphas. And this makes it convenient to express the state using a combination of few vectors, the basis vectors, as in Dirac notation. There are 3 operations: initialize a state, transform it, the actual computation is the transformation of the state, and measure, in other words, extract the information. So there is this feature in quantum computation, unique to quantum computation, extracting the information from the data structure. To initialize the data structure, we say that we simply initialize each qubit to the state 0 or state 1. To transform, we multiply the state vector by a unitary matrix. And a unitary matrix is such that its inverse equals its complex conjugate, as is evidenced by this formula. In a sense, the use of unitary matrices is natural because unitary matrices preserve norm, and we want to preserve the norm because in our case, norm is the probability. So we don't want the probability to be equal to overall probability to be equal to a non-unit number. So let me give an example of a transformation. So Rx, the x rotation by the angle theta, is described by this matrix. By substituting theta equals pi over 2, you can convince yourself that this operation implements the NOT gate. Indeed, it maps ket 0 to ket 1 and ket 1 to ket 0. And this factor in front is irrelevant. Indeed, it's a complex number with norm 1. And we don't care about things that have the norm 1 because they don't affect the probabilities. A very important example of a quantum gate, in particular for the purposes of this presentation, is the Hadamard gate that is defined through this matrix. It's, of course, once we define it through the matrix, we can tell what the result of the application of the Hadamard gate is. Important to highlight here is that what Hadamard gate does, it performs reflection about this axis. So in particular, it takes the ket 0 and maps it into ket 0 plus 1. And if Hadamard gate is applied to 0 plus 1, it maps it back to 0. And it takes ket 1 and maps it into 0, negative 1. And if you apply Hadamard to 0, negative 1, you get back to ket 1. these are important properties to remember for the rest of the talk. Finally, the process of measurement is a projection. In other words, when you have a quantum state and you measure it first time, then you get 0 with probability alpha squared and 1 with probability beta squared. Every follow-up measurement will give you the same exact result. Therefore, you get non-trivial information only the first time that you measure. So you have to be careful about when it is that you decide to measure a quantum mechanical system. Quantum algorithms are circuits. What are circuits? Circuits are time evolution of a quantum description of time evolution of a quantum mechanical system. In other words, if y coordinate is the three-dimensional space in which the qubits live, then the x-axis is the time evolution of quantum mechanical system, where these boxes correspond to the gates that you apply in respective periods of time to the individual qubits. And this describes the process of quantum computation. All right, now let's take a look at that quantum algorithm that solves a problem more efficiently than a classical algorithm ever could. Suppose you have access to this black box. And what this black box does is it has 2 inputs and 2 outputs. So it takes the input, computes the value of f, and XORs it to the second input, and it outputs it. So the first input passes unchanged, and the second XORs with the f of the first input. The reason we need this funny black box is because everything has to be reversible in quantum computation. So if we are to compare quantum computation and classical computation head to head, we need to deal with reversible objects. Suppose the goal is to determine the value of f of 0 exclusive for f of 1. A classical algorithm will need 2 queries, because with 1 query you can learn only one of the 2 possible numbers, and the second number will determine the value of f of 0 plus f of 1. However, with a quantum algorithm, it suffices to use only a single query. Let's see how. To see how, consider this circuit. It has 3 computational stages. So if we run through this circuit and we convince ourselves that it does indeed compute the desired answer, that this will prove that the problem can be solved with a single query to the black box. And the reason is, well, we use this black box only once, right here in the circuit. Okay, so let's execute stages 1 to 3 and convince ourselves that we do get the correct answer. When we have input 0, 1 and we apply the Hadamard gates to it, the Hadamard gate applied to 0 gives 0 plus 1. The Hadamard gate applied to 1 gives 0 negative 1. Let's go to the next step. In the next step, we want to apply this box to this vector. This is the result of the computation. You can convince yourself that this is indeed the case by substituting each of the 4 possible matrices for the function f, and that the result of this computation, as described by this formula, is correct. So I could have instead shown the set of 4 different vectors that would compute the correct answer, but it is more convenient to express it as a short formula, and you can directly verify that this short formula is correct. Third stage, we need to apply the Hadamard gate to the first qubit. So let's see what we have. If f of 0 equals f of 1, this means that this number is the same as this number, and both are plus minus 1. So we can factor out the plus minus 1, and inside the brackets we will have 0 plus 1. So 0 plus 1. If we apply Hadamard gate to 0 plus 1, we get 0 by the definition of what Hadamard does. If, however, f of 0 is not equal to f of 1, then this number and this number, they have different signs. So we can factor them out, and inside the brackets we will have 0 minus 1. Applying the Hadamard gate to 0 minus 1 gives 1. As you can see, measuring the first qubit gives 0 if f of 0 plus f of 1 equals 0, and it gives 1 if f of 0 plus f of 1 equals 1. Therefore, we obtain the desired answer with just a single query to the given black box. Therefore, given a quantum advantage. Now you may say, and that would be a very good question, that, all right, suppose you convince me that quantum algorithms are more efficient than classical algorithms. However, the problem that you showed is not particularly practical. Is there anything practical that we can do with a quantum computer? And the answer is yes, we can. Let's see. Let's consider a few examples. So one that I would like to focus on is the process of nitrogen fixation. It's a process that is required for the creation of fertilizers, and it is accomplished by the Haber process. A potential problem with the Haber process, or the problem with the Haber process, is that it requires that the material is heated up to a very high temperature of between 300 to 400 degrees centigrade. And because we produce, as a humanity, fertilizers in large quantity, heating large quantities of materials to a high temperature is expensive. In fact, it has been estimated that about 1% of the energy that humanity produces in a given year is being used to fuel the Haber process. So if we could come up with a different chemical process to perform nitrogen fixation, we would save a lot in energy. So let's focus on this example, high performance polymers. In fact, with a quantum computer, and it's perhaps quite natural that with a quantum computer we would be able to simulate quantum mechanics very efficiently, we will be able to simulate the materials efficiently. This is because the basic properties of the materials are based on the quantum mechanics, on the underlying quantum mechanics that happens on the molecular level. So if we have a scalable quantum computer, then we should be able to compute properties of materials. Related to this is an application where we would design drugs using a classical computer. And drugs are large molecules, but they behave quantum mechanically. So if we could develop a large enough computer to simulate large molecules, then we would be able to perhaps develop drugs using a quantum computer. So finally, let me focus a little bit on this application, the design and development of batteries. So it is perhaps natural that quantum computers would be helpful in increasing the number of recharging cycles in the batteries computationally and improving the charging times of the batteries. But there is more than quantum computers can do for the batteries. So what is a battery? A battery is a storage of energy, and an efficient battery is a storage of a lot of energy. So this makes the battery be somewhat similar to a grenade, as in hand grenade. It is also an object that stores a lot of energy. However, we don't want this energy to be released too fast. And what may happen is, and you may even have experience with that happening, is if you take a battery and if you puncture a hole in it, it may happen that this will set the battery on fire because the release of the energy will become too fast and the chemical reaction going on will be too fast. We can compute if this does or does not happen if we have a quantum computer. Therefore, by simulating puncturing the hole in a battery, we could computationally predict whether it will set on fire or it will be safe. This is, again, an important problem to be able to solve. All right, suppose at this step I convince you that quantum computers would be able to solve useful problems. However, maybe there is no hardware that operates according to quantum mechanical principles. May that be the case? And if that is the concern, then the answer is, well, there is hardware. So let's see what's available. Since the year 2016, IBM started introducing quantum computational hardware, and it is available via IBM Quantum Cloud. You can access it for free. The smallest computer is a 5-qubit computer. It was introduced in 2016. So the dots or the nodes on the slide represent the individual qubits, and the edges represent the connections. As you can see, it started with 5 qubits, and then it grew to 16 qubits in 2018, and then 20 to 58 qubits in 2019, and then in 2020 it's up to 65 qubits, and this year in fall we expect to be able to release a device with 127 physical qubits. So this is how a quantum processing unit looks like, taken outside the fridge. This is where the actual qubits live. And the QPU quantum processing unit is put in the dilution refrigerator because this is a superconducting technology, and you need to cool down the quantum processing unit for it to be operational to a near 0 degrees Kelvin. And this is accomplished by the dilution refrigerator. And here, of course, shown is the chandelier of the dilution refrigerator without the cover. And I guess without the cover, it's not going to work because of the light incoming and heating everything up. So it needs to be shielded. And here it's illustrated without shield. Just wanted to point it out. Next question. All right, so you so far developed devices with dozens of qubits, but this is not yet enough to solve interesting problems. When we will be able to solve the interesting problems? And a partial answer to this question perhaps follows from the roadmap. Of course, it's impossible to predict the future. But if there is a roadmap and it is followed, then it gives some sort of confidence of what's going on and what is about to happen. So up to 433 qubits, it's going to be called IBM System 1. And then for larger devices, it will need to be a different family of systems. So, and of course, this different family of systems is where the scalable quantum computations live that solve problems of practical importance that we care about solving. So 27 qubit device and 65 qubit device were already released. In fact, 27 qubit device was released in 2019 and 65 qubit device was released in 2020. 127 qubit device we plan to release this year. In terms of the key advancement that went into releasing the respective devices, in 2019 it was optimized lattice. In 2020 it was scalable readout. For the system that we're planning to release this year, the key advancement is novel packaging and better controls. For 433 qubit device, it's miniaturization of the components, and then integration, building communication between the various fridges, perhaps, better infrastructure, developing and deploying scalable quantum error correction for, of course, those larger devices with perhaps millions of qubits. Let me say a few words about what IBM Quantum is. So the major focus at IBM Quantum is on the development of quantum systems. And this consists of developing hardware, developing software, as well as performing research in quantum computing. The reason is quantum computing is a very young field, and a lot of it is still basic research. So we have to be able to push the edge of research along with the development of relevant hardware and software. Other than that, IBM Quantum focuses on open source projects, the API, development of the workforce, education, development of a software ecosystem, as well as accelerating commercial adoption and familiarity with quantum technology in industry. What matters in quantum computation is very similar to what matters in classical computation. And in particular, being the ICPC crowd, I hope you would relate to what I'm going to say. And when you're given an ICPC challenge problem, your goal is to develop an efficient solution. This means an algorithm and implement it efficiently, such that the time to correct solution is minimized. And this same exact problem is very important in quantum computing. In fact, it is even more important because quantum hardware is very expensive and unreliable. Therefore, the ability to reduce the size of the program and the size of the computation is even more important in quantum than it is in classical. And I believe reducing the size of the computation and making it more efficient is what ICPC is all about. And because of that, I hope that there may be interest from the ICPC community in quantum computations. I am happy to answer any questions concerning IBM Quantum or quantum computing technology or quantum computing. Please reach out to me by email or contact me during the quote-unquote office hours when I will be explicitly available via WebEx. Thank you very much.